Days of warning, night brings morning. My prayers worthless, heaven is burning down. I walk stricken, it's black vision. Oh, one, save me, caress my weary eyes. Darkest Lord, your mercy shall I gain. Straight the match and go the earth in flames, in flames, in flames, in flames.
Okay, what's up everybody? Welcome to my channel. We're going to continue going over the 12 articles that I have up on my site, thesleeperagent.com. Let me see what time it is. Alright. I will have to make this not too long. I do have some plans later, so I'm going to make this video, and this is kind of there's no articles up there that are long, so but this is basically building off the video from before where I talked about the importance of animal disease. And this is all relevant to my recent book, The Sleeper Agent, The Rise of Lyme Disease, Chronic Illness, and the Great Imitator Antigens of Biological Warfare. Now, I have this book coming out on Amazon December 13th. I am selling it at my site, thesleeperagent.com now. But I'm trying to put I have published a bunch of articles that go over key areas that are important to understanding. And let's see, the first video article that I did was on Eric Traub. The second article I did was about the importance of the two classes of biological agents, those that kill and those that incapacitate. The last video I did was discussing the importance of animal disease in the history of biological warfare programs and agricultural facilities and research, or biological warfare research that is kind of hidden under agricultural problems or agricultural research. In this article, it is called Animal Pathogens and Biological Warfare, Bioengineering in the Days Before Recombinant DNA. Recombinant DNA is the term for the modern genetic engineering technology that came into existence in about the 70s. I think the mid 70s or late 70s and early 80s. It's called recombinant DNA. Using the genetic engineering technologies and labs, fancy lab equipment or whatever. And basically what has to be understood before reading my book is that genetic engineering could be done in other ways. And before the days of recombinant DNA, they used animal passages, or what is called serial passages in animals. And what this means, an animal passage is you infect the animal, you let the disease play out, and then after the disease plays out, you re-isolate the agent from the animal, then you run it through another animal, right? Let it play out, re-isolate it, then you run it through another one, and that's, in a sequence called serial passages. But a lot of the genetic engineering back then had to do with adapting it to different animals, because certain animal passages, like, for example, running an agent in serial passages in mice raised the neurotropic qualities of any agent. That means it raised its ability to take to the central nervous system and the brain. Why it raised neurotropism? Why mouse passages raised the neurotropic qualities? We don't really know, but it did, and that was something they noted. And then likewise, other animals, and I believe it was chicken eggs and chicken passages raised the cardiotropic and the myotropic qualities, the ability for it to take to the heart and the musculoskeletal system. And it seems that it was also the point where a lot of agents that when adapted to chicken eggs would also take to humans, and most likely is because of the similarity between the human and the avian mucosal immune system. A similar immune system. And they have very similar B cells to us. But I will put an image on the screen. I'll hold this up right here, but this image, this is a little diagram taken from one of Eric Traub's papers where he was adapting the foot and mouth disease virus, which is generally a virus of cattle, which causes blisters on their hoofs and their mouths. That's why it's called foot and mouth disease. And in this diagram, he's alternating. So first he adapted foot and mouth disease to mice, right? It raised the neurotropic qualities of foot and mouth disease. And in this one, he's adapting it to eggs, chicken eggs. And so what he would do is alternate. He would run it through a mouse, then he would run it through an egg. Then he would re-isolate it, run it back through a mouse, then back into an egg. Then back into the mouse, and back into the egg. And then he would try, after 3 passages in the egg, he would run it through another egg after the egg to see if it would maintain the infection in the egg without having to go back to the mice, and it didn't. So he would continue alternating. And he did that, and after the 8th passage in chicken eggs, he ran it through an egg after that, and it maintained, but then after, on the 3rd passage in an egg, it didn't maintain. So basically the idea was he would gradually get the virus used to an egg, and it was already adapted to the mice, so that's why he was running it back into the mice, and then back into the egg, back into the mice, because it was already used to the mouse. So he was trying to adapt it, get it used to the egg. And what he did was he mixed 10 strains of foot and mouth disease virus in one egg to get it to take originally. But see, this was back in the 1940s and 50s, and this was kind of his schema or methodology for adapting just about any disease agent to any kind of animal. He would use an animal that already infects and had already taken to, and then he would kind of alternate between that one and the animal that he wanted to adapt it to. So he gets slowly used to that animal, or the egg. And after in this diagram, after running it in in an alternating sequence for 12 times between the mouse and the chicken egg, then it could maintain itself for an uninterrupted number of sequences of passages in the chicken eggs. I know this sounds kind of confusing, but the basic idea here is that he would slowly get a disease agent used to an animal, and after a while it would mutate, and then after that mutation occurs, it takes to that animal and it can infect that animal permanently, and in as many sequences in that animal, or as many serial passages in that animal back to back as you could possibly do. And this was the method of genetic engineering before modern genetic engineering technology. This is what he did. Animal passages. And this became a fine art for Eric Traub. And he would often use animal viruses as well to get things to infect. Like he used an animal virus, or a form of influenza virus that infected hamsters, to get a blood parasite that didn't infect hamsters to infect hamsters by using he would use these animal viruses as well. This is a little different than what I had just shown you, and it's kind of a complex science, so I'm not going to describe it here, but the basic idea here is just to show that long before modern genetic engineering technology was available, this is how they genetically engineered viruses and microbes to have biological warfare, techniques long before the days of genetic engineering in the 70s. And that's often, because that's often the argument, that is used to dispel the Lyme disease connection to biological warfare. They go, well, the genetic engineering technology wasn't quite there yet. As though that was the only possible way to do it. And we know that Traub used a completely different methodology, and even today, for biological warfare, nobody uses the modern genetic engineering technology because it leaves footprints, and it leaves, fingerprints. It leaves evidence of tampering. And if there's evidence of tampering in something that is released as an agent of bioterrorism, then that means that it's also more likely that they may be able to find out who had done that. And that's the whole point of biological warfare is something that a lot of countries used, like in the Cold War, because they could get away with saying it was an act of nature. They couldn't get away with using chemical weapons and saying that, but they could get away with saying, oh, it was a natural outbreak if they used a biological agent as an agent of bioterrorism. As long as there's no footprints or fingerprints of tampering, it's nearly impossible to conclusively say that it was an agent of bioterrorism, unless, of course, you have like a trail of evidence that is left behind in other ways, like I have of Eric Traub with the Lyme disease spirochete and the weaponized ticks. But the whole thing about using animal passages it was so desirable, and still is today, even with modern genetic engineering technology, because you can say, oh, it came from an animal. Even if that animal is being used in a lab and you're directing it between these animals, the closest you're going to get is like, well, this virus is closest to the one, in this animal. Like, for example, they said about the coronavirus, they go, oh, well, it's closest to a coronavirus of sea snakes or bats. But if they had those animals in a lab, like if they had the sea snakes in a lab or the bats in a lab, in cages, and they're running it through these animals, in alternating passages to get it, to change its properties, that's still a biological warfare agent that has been bioengineered. And oftentimes the two animals, the back and forth passages never would have happened in nature. So it's basically fast forwarding a process that is either most likely would never happen in nature, or something that is very, very, very unlikely to happen in nature, and you're kind of like directing it to happen. So this is a big deal to understanding, and this is also another reason why veterinarians were often the best bioweaponeers. And Eric Traub was a veterinarian. Now, he was a virologist, and he spent his entire life working in virology, but he was essentially trained as a veterinarian. And he had a very good understanding of how to change viruses certain ways by the animals chosen to run it through. And that's kind of the whole idea here. And I'll show another image on the screen that shows, now this is one of his German papers from World War II, and you can see that this methodology could get very complex. But this is basically all I wanted to show in this article, because as my book is released on Amazon and everything, I'm sure there'll be attempts to dispel, and I'm sure they'll come up with that explanation again, saying, oh, well, the recombinant DNA technology just wasn't there yet. Like in that article by Sam Telford and David Persing, where they said it was called something like, no, Lyme disease is not a biological warfare agent, despite what conspiracy theorists say. And he cited that argument that the modern genetic engineering technology just wasn't there yet. But it was absolutely irrelevant because of this, because of these animal passages and how to mutate it that way. And even today, this would still be the go-to, because biological warfare is a form of war that no country wants to get caught using. And so they make it as plausibly deniable as possible so that they can say, A, that it was a natural outbreak, we didn't release that, it just happened, to show up at this time. And also, they don't want to leave any footprints of genetic engineering technology. So animal passages are perfect for that. So that's it, and I think I gotta get going here, but I was thinking to myself this morning, I was like, man, I am really hurling myself into the lion's den here, and thinking to myself, why am I even doing this? It's like, 99% of the people could care less, and they'll get mad at me for saying, for bringing all of this out, and for publishing my book, and everybody will try to tell me I'm wrong, this and that, and I'm not wrong though. And I've got that wonderful introduction by John Loftus, and basically, you know, his sources were telling him that I am spot on with my work. I know it's good work, I know it's quality, I know I am correct in what I'm saying, and I am very confident with my book. So, but you know, this is a sacrifice. This is a sacrifice. Do I want to get publicly crucified? No, I don't. But at the same time, I mean, the world is so effed anyway. It's like, if you're not going to try and you know, add what you can to make this a better world, then you might as well just give up. So that's it. I think in the next video I am going to go over why nations hide their biological warfare programs under benign research. So with that said, everybody take care of yourself, be yourself, build yourself, and I will see you on the other side.
Just on the other side. Not that I can, or that I want. Let it burn under my skin. Let it this life to set me free. Took a piece of you inside of me. All this hurt can finally fade. Promise me you'll never feel afraid. Not that I can, or that I know you'll find your own way when I'm not with you. So tell everybody, the ones who walk beside me, yeah, I hope you'll find your own way when I'm not with you tonight. I hope it's worth it, what's left behind me, yeah. I know you'll find your own way when I'm not with you. So tell everybody, the ones who walk beside